Picture this, a megacity, home to millions of people, literally choking under a thick, gray blanket of toxic smog. Schools are shut down, hospitals are completely packed. Just stepping outside and breathing the air, it's basically like smoking a pack of cigarettes a day. So, faced with this kind of total environmental paralysis, governments aren't just sitting around waiting for a natural miracle. They are looking upwards for a technological rescue. Welcome to this explainer. Today, we're diving into a genuinely fascinating, and yeah, pretty controversial, intervention that sounds straight out of science fiction, but it's happening right now, right above our heads. We're talking about engineering the weather itself.
Okay, let's dive right into this. To really master this topic, here is our roadmap. We'll start with the crisis, break down the concept, move into the mechanism, weigh things up in the impact matrix, look at a real-world case study from Delhi in 2025, and wrap it all up with a quick exam revision.
Number 1. The crisis, engineering a solution. All across the globe, megacities are slamming into unprecedented urban air pollution, crippling water stress, and wild climate variability. And you know, these aren't just environmental issues anymore, right? They're full-blown economic and public health emergencies. This is forcing policymakers to look at some incredibly drastic, rapid response measures. Which brings us to this really provocative question, one that totally reframes how we look up at the sky. See, we're no longer just thinking of weather modification as this neat trick to help farmers out during a drought. We're now asking if we can deploy it as an emergency disaster response. Like, can we literally wash the toxic smog right out of the air we breathe?
Part 2. The concept, what and why.
So the technical term you're going to hear is cloud seeding. By definition, it's a weather modification technique aimed at enhancing precipitation by stimulating rain or snowfall from suitable clouds. Now pay close attention to that keyword right there, enhancing. We are moving from pure meteorological theory into actual physical chemical interventions in our atmosphere. We aren't just magically conjuring clouds out of thin air here. No, we are manipulating the ones that are already floating up there.
And this brilliantly illustrates the two totally different ways we actually pull this off, entirely depending on the environment. It helps to think of these as two distinct mental models. On the left, we've got hydroscopic seeding. Just think warm salt. We use this in tropical regions where you have warm liquid clouds. We inject salts, like everyday sodium chloride, and these act like tiny magnets for moisture. They make water droplets merge and grow until they're heavy enough to actually fall. Now on the right side, we have glaciogenic seeding. For this one, think supercooled ice chemicals. This method targets those freezing, high-altitude clouds, using agents like silver iodide or even dry ice to literally force the formation of ice crystals. Basically, the environment completely dictates the chemistry we use.
Number 3. The mechanism, how it works.
Okay, so how does the operation actually flow? It comes down to 3 fundamental steps. Step 1 is the absolute bottleneck here. You have to identify suitable, moisture-laden clouds. You literally cannot generate rain out of a clear blue sky, and you definitely can't make it rain if the air is bone dry. Then comes step 2, deployment. This is where you disperse your chosen seeding agents directly into those clouds. Usually this is done using airplanes, though sometimes they use rockets or even ground generators. And finally, step 3 is where the chemistry happens. Those dispersed agents act as condensation nuclei. Basically, they give all that scattered moisture a solid core to cling to, which causes those tiny droplets to coalesce, get heavy, and boom, precipitate as rain or snow.
4. The impact matrix. Let's take a step back and weigh this out neutrally. On the left side, the promise is, it's incredibly appealing. We could augment water supplies during crippling droughts, support critical agriculture, calm down severe weather like destructive hailstorms, and super importantly for those choking megacities, temporarily wash away airborne pollutants. Sounds great, right? But then, look at the stark reality on the right. This whole process is insanely resource-intensive, with an astronomical economic cost per square kilometer. Plus, you have that strict, totally non-negotiable need for pre-existing cloud moisture. Then you've got the ecological and governance concerns. Prolonged use of silver iodide? That raises some very valid fears about heavy metal toxicity building up in our soil and water ecosystems. And overarching all of this is a cloud of scientific uncertainty. The hard empirical evidence proving its effectiveness, especially for clearing out persistent urban smog, is still highly debated.
5. Case study, Delhi 2025. To really wrap our heads around these limitations, we need to step out of the theory and look at a real-world application. Let's dig into a fascinating, highly ambitious experiment.
This is perhaps the very first attempt in an Indian megacity to deploy this technology specifically to fight pollution, rather than just helping out with a drought. The objective was straightforward, but man, technologically, it was daunting. The goal was to trigger artificial rain to literally scrub the sky of hazardous PM2.5 and PM10 particulate matter. The setup required massive interagency coordination. We're talking meteorological departments, aviation authorities, and academia all teaming up. Specifically, they rigged up an IIT Kanpur-managed Cessna 206H aircraft to disperse a custom mix of silver iodide and highly refined salts right over the capital.
Now, what's really wild to think about here is the financial weight behind this pilot project. The Delhi government approved a budget of 3.21 crore rupees. And get this, that entire budget was allocated for just 5 aircraft-based trials, with each flight only lasting about an hour or maybe an hour and a half. This perfectly highlights that intense economic reality we just talked about in the impact matrix. It's a massive, massive financial investment for a highly localized, super brief intervention.
Tracking the chronological timeline of this project is incredibly revealing. It wasn't just a simple matter of saying, hey, let's fly, and taking off. The original trials were actually slated for early July 2025, but they had to be postponed right out of the gate. Why? Unfavorable weather and extremely low cloud moisture. So they hunted for alternate windows all through late August and September. Finally, on October 28, 2025, they got their opening. 2 sorties were successfully flown over Delhi, and they deployed the chemical flares exactly as planned. From a purely operational standpoint, the interagency coordination, the aircraft modification, the deployment, it was a total success.
But here's the catch. Meteorology doesn't care about operational success. Just look at this stark visual contrast. For artificial precipitation to actually work, you generally need a cloud moisture content of around 50 to 60%. But during those late October trials, the actual cloud moisture over Delhi was sitting at a dismal 10 to 20%. So the operation itself was flawless, but the atmosphere simply didn't have the raw materials to work with. Because of this massive gap, that 3.21 crore project resulted in only a negligible 0.1 to 0.2 millimeters of trace drizzle. And to make matters worse, even that tiny bit of rain fell outside of central Delhi.
The ultimate outcome of the whole endeavor is summarized perfectly right here. Despite all that cutting-edge technology and the huge funding, the air quality index remains stubbornly stuck in the poor to very poor range. This case study really hammers home a vital lesson. Winter seasons in cities like Delhi are just inherently dry. So pollution peaks at the exact same time the atmospheric conditions for cloud seeding are at their absolute worst. The harsh reality? You just cannot force rain out of dry air.
6. Exam revision and final takeaways.
All right, congratulations on analyzing that entire complex breakdown. You've seen the theory, the execution, and the stark real-world results. Now let's synthesize all of this into actionable knowledge. Here are your 5 visual memory anchors. First, know the chemistry. Hygroscopic uses salts for warm clouds. Glaciogenic uses silver iodide for cold clouds. Second, remember the absolute prerequisite. It demands pre-existing moisture, around 50 to 60%. It's not magic, it absolutely cannot work in clear skies. Third, weigh up the matrix. You're balancing extremely high operational costs against potential heavy metal toxicity. Fourth, keep the Delhi 2025 pilot in mind. It proved the logistics are totally possible, but it fundamentally failed to reduce pollution because moisture was just sitting at 10 to 20%. And fifth, the ultimate policy reality. At best, cloud seeding is merely a short-term supplementary band-aid.
Because the overarching conclusion from all this data is crystal clear. Technology cannot replace structural environmental governance. If we actually want breathable cities, long-term strategies are strictly non-negotiable. We absolutely have to focus on the source of the problem, pushing for aggressive emission reduction, building up urban forests, implementing truly sustainable city planning, and prioritizing nature-based watershed management. We've got to treat the disease itself, not just put a Band-Aid on the symptoms.
Which leaves us with this final, really important thought to analyze. As our climate stress worsens and our cities continue to choke, where should we actually be directing our billions of dollars and our brilliant minds? Are we better off trying to engineer the sky to clean up our mess, or doing the hard structural work of fixing the emissions down here on the ground? Think deeply about that balance between quick technological fixes and enduring environmental governance. Keep learning, keep questioning, and I will see you in the next explainer.